Hello everyone, in this video I'm going to go over how to convert from moles to grams. So this is just taking those moles to moles problems one step further and getting the final answer in grams. So again, these are stoichiometry problems, so we need the chemical equation. This one is already balanced for us. So I'm going to jump right into starting the picket fence. So the question is, if there are 8 moles of HCl, so that's what I'm given, that's what I'm going to start my picket fence with. Again, make sure that you're writing moles and of what substance. And then the question is, how many grams of magnesium chloride? This is magnesium chloride, magnesium and then chloride, so MgCl2. Would be formed. So again, if you ever have moles, whether you're starting with moles or you get to that point in your picket fence, once you have moles, you must use the balanced chemical equation. Again, the numbers in the front here represent moles, and we'll put ones here as a placeholder. So again, anytime you're doing a picket fence, whatever unit is here, I always write the same unit in the bottom because I'm going to want them to cancel. So moles of HCl. Now where am I going to get that number from? The balanced chemical equation. So according to the balanced chemical equation, 2 moles of HCl. And then whatever goes above this, that number should also come from the chemical equation. Now, the substance that goes up here are moles, because we're getting that number from the chemical equation, of the substance we want our answer in. So the question is, how many grams of magnesium chloride? Well, before I get there, I have to convert into magnesium chloride first. So according to the chemical equation, 1 mole of magnesium chloride. So all I've done so far is moles to moles. I've gotten moles of HCl into moles of magnesium chloride. However, I need my final answer in grams of magnesium chloride. Well, this is what we did last semester. We just have to convert moles into grams. And to do that, you need molar mass. So magnesium chloride, so we have to find the molar mass of that. Remember, molar mass is 1 mole, and in this case it's magnesium chloride, is equal to, and we have to calculate the molar mass of that using our periodic table. So I have magnesium, which is 24.305. So I'm just going to do that over here. Plus we have 2 chlorine, that's MgCl2. Chlorine is 35.45. I'm going to go ahead and calculate that. So 2 times 35.45 plus 24.305. So that is 95.205. So 95.205, remember this is grams, that's molar mass. So now moles of magnesium chloride cancel, and I'm just left with grams of magnesium chloride. So I'm going to multiply everything in the top. So 8 times 1 times 95.205. And then we're going to divide it by everything multiplied together in the bottom, which is just 2. We get our final answer, 380.82. 380.82 grams of magnesium chloride. Make sure you're writing for your final answer if it's in grams or moles, and then what substance it is. I'm going to go ahead and do another example. So sodium, very reactive. Sodium metal is extremely reactive. If you throw it into water, it explodes. And this is the reaction for that. So we have our balanced chemical equation here. So I'm going to go ahead and jump into the picket fence. So if there are 10.5 moles of sodium, that's what I'm going to start my picket fence with. Sodium is Na. How many grams of hydrogen gas would be formed? So that would be H2. Again, if you are ever starting with moles or you get to moles in your picket fence, you need to use the balanced equation. Again, these numbers in the front here represent moles. And again, in our picket fence, I'm going to start with writing the same unit here and here because I want them to cancel. So moles of sodium, I'm going to get that number from the balanced equation. So 2 moles of sodium. And then above that, I'm going to put moles of what I want my answer in. So in this question, it's asking for how many grams of hydrogen gas. Well, I need to convert into moles of hydrogen gas first. I need to convert into hydrogen first. According to the equation, 1 mole of H2. So again, all I've done is convert moles of sodium into moles of hydrogen. However, I need the answer in grams, so I'm going to have to find the molar mass of hydrogen gas, which is H2. So molar mass always states 1 mole is equal to the number of grams, which is calculated from the periodic table. We get that number from the periodic table. So hydrogen is 1.008, and we have to multiply that by 2 because the formula is H2. So I'm going to do 1.008 times 2, so 2.016 grams of hydrogen gas. So all we did was convert now moles into grams. Now I multiply everything in the top. So 2.016 times 1 times 10.5 divided by everything multiplied together in the bottom, which is just 2. So 10.584. So 10.584 grams of H2, which is hydrogen gas. Again, if you ever have moles, make sure that you use the balanced chemical equation to convert from moles of one substance into moles of a different substance. All right, let's say now we are starting with grams instead, okay? So I have my balanced chemical equation here. This is just a typical combustion reaction. This is methane gas is CH4, and this is the combustion of that. So if you were to set methane gas on fire. So how many moles of carbon dioxide, which is CO2, are formed if we use this many grams of methane? Again, methane is CH4. So I'm going to start my picket fence with the number that was provided to me in the problem. So grams of methane. Methane is CH4. So I'm starting with grams this time. So like I was saying in the last problem, if you have moles, you need to use the balanced equation. Well, we need to get into moles first, so then we can use the balanced equation to convert from one substance to the other substance. However, since I'm starting with grams first, I need to get grams into moles, and I do that by finding molar mass, okay? So I'm going to have to calculate the molar mass of CH4. So all I'm doing is converting grams into moles by finding molar mass. So carbon is 12.011 plus there are 4 hydrogens, so 4 times 1.008. So 1.008 times 4 plus 12.011. So 16.043 grams. So all I've done is convert grams into moles, which we've done before. However, I need my final answer in moles of carbon dioxide, and right now I am in moles of methane. So again, I'm going to write same unit here, moles of CH4. Now I'm going to get this number from the balanced chemical equation. Again, you can assume that there's a 1 here in the front, so 1 mole of CH4. And then above it is going to be what I want my answer in, which we want moles of carbon dioxide. And moles of carbon dioxide, it also happens to be 1 mole as well. And sometimes that happens where it's a 1-to-1 ratio. So my units cancel. I'm just left with moles of carbon dioxide, which is what I wanted my answer in. So I multiply everything in the top, which is 457.54, divided by everything multiplied together in the bottom, which is 16.043. I'm going to get 28.520 moles. I'm going to go actually 4 decimal places. So 52 moles of carbon dioxide, which is CO2. Let's do another example problem. So this is this is a catalytic oxidation of ammonia. So here I have my balanced chemical equation. So again, I have the balanced chemical equation. I could go right into my picket fence. So I am given 824 grams of NH3, which is ammonia, and I need to get that into moles of NO. So that would be nitrogen monoxide. So since I'm in grams, the first thing I have to do is convert grams into moles. So I have to find the molar mass of NH3. All I'm doing is converting grams into moles using molar mass. So hydrogen is 14.007 plus we have 3 nitrogens, so 1.008 times 3 plus 14.007. So that is 17.031 grams. And I'm going to convert that into moles of NH3. However, I need my final answer in moles of NO, which is nitrogen monoxide. So I'm going to write my unit here so they can cancel, moles of NH3. Now this time I'm getting it from the balanced chemical equation, which is 4. And then above that, I'm going to convert to the substance I want my answer in, which is NO, that's nitrogen monoxide. And according to the balanced equation, that is also 4. Now, if you were to simplify this and put 1 and 1, that is fine. That's still going to give you the same answer. But if you don't do that, that's okay too. It's 4 over 4, which is still 1-to-1. So I would multiply everything in the top. So 824 times 1 times 4 divided by 17.031 times 4. I'm going to get 48.38 moles of nitrogen monoxide, which is NO. So again, if you have grams, then you need to find molar mass to get grams into moles, like we started with these 2 picket fences here. In this situation, we started with moles, so we were able to go into using the balanced chemical equation right away to get moles of one substance into moles of a different substance, and then we used the molar mass to convert into grams. For these 2 problems, once we had our grams into moles, then we use the balanced equation. So don't try to memorize how to do these problems. Just remember, if you're starting with grams, get it into moles first by using molar mass. If you're starting with moles, and then you can convert into moles of the other substance. And if you're starting with moles first, get that into moles of the substance you want using the equation, and then you can convert into grams by using molar mass, okay? So as long as you remember those things, you can do any type of picket fence with these types of problems.